So you know that we do have two categories of routing protocol. We have IGPs versus we have the another, which is EGP. So this is what basically the major category of the routing protocols we have. So when I say the differences between IGP versus EGP, so I'll say that the very first point, or what we can do is we can create a table for the comparison. This side I'm gonna write IGP, the interior gateway routing protocols, and this side will say EGP, the exterior gateway routing protocol. Now let's try to see the differences between the IGP and EGP first. So talking about the very first point in the IGP protocol, the point is that the IGP protocols are going to have the visibility of topology. So when I say visibility of topology, that's a really important point, which will help you out to understand the BGP part throughout the entire NRC training. So I'll explain the point, but let's talk about EGP. So in case of EGP, EGP is something it doesn't have the visibility of the topology. So I'll simply say doesn't have the visibility of topology. And to have the visibility of topology, it actually relies on IGP protocol. Now, what I mean by that point, guys, when I say visibility of topology, you know that every IGP routing protocol is going to have its own algorithm, which is going to help the routing protocol to take the forwarding decisions, to help the device to, figure out the best path, to maintain the database, to manipulate the database, and so many things like that. So if I do talk about the algorithms, we do have two algorithms. Let's say dual algorithm is there, that is going to be with the EIGRP, which is diffused update. And with OSPF, we have something shortest path first algorithm is there, which helps the OSPF process to make sure that the best path is being selected, and then accordingly the decisions will be taken on. So if I do take an example, like I do have some routers, let's say router 1 is there, there is some router 2, there is some router 3 and 4. So all these routers are internally connected with each other. Now, assuming that all these routers are configured with OSPF. So in case of OSPF, you know that the router 1 will have the information about the networks which are there on the router 4, assuming that on the router number 4, we are having some network, let's say 10.0.0.1. We have some 10.0.1.1. We have some 10.0.2.1 with the /24 value subnetted network. So with this diagram, if I am saying that the router number 4 is having three different networks, so router 1, router 2, router 3 will definitely have the information about all the routes which are being installed in the routing table of router number 4. So this is all just because of the algorithms which makes the IGP protocols more better. So that is one thing, that they do have the complete visibility of the topology. But talking about EGP protocols, assuming that this scenario is now configured with another protocol that is somewhat like the BGP protocol. So BGP is not like the LAN kind of thing. It's on always be on the WAN interfaces of the devices. So internally, what's going to happen inside the network, it doesn't care about the LAN segments. So if BGP is there with the enterprise network, and with BGP, if you want to make sure that you should have the entire routing table, or your BGP routers must be able to see that what are the LAN segments. In that case, BGP has to rely on IGP protocols just to have the complete visibility of the topology. So that's one point we can say. And another point I'll say is, the second point will say IGPs are always going to decide on the link attributes. So that's one thing. What I mean by that is, so link attributes in the sense is just nothing but the cost which belongs to the link. So they don't actually care about the prefix. So I'll say here, not the prefix. So all the IGP routing protocols will take the decision according to the cost of the link. But talking about eBGP or EGP, BGP, sorry, you can say, I'll simply write here BGP because all these points are signifying BGP only. So BGP is something, it decides on the prefix vector because we know that BGP is actually a path vector protocol. We'll let you know that later on. So I'll simply write the point. It decides on prefix vector attributes. That's one thing. That is the attributes belongs to the prefix, not to the link. So I'll say attributes belongs to the links. Sorry, to the prefix, not to the links. So attribute belongs to the prefix, not to the links. So that's one point, and I will let you know this point later on. So that's one thing we have. And then talking about the policy implementations of your BGP or IGP. So if I say the policy implementation part, talking about the policy implementation of BGP, BGP policy application is easy. We'll let you know in the labs. So this point I'll explain you in the labs, guys. And talking about the policy applications, it's a bit hard in IGPs. So IGP policy application is hard. And also the second thing is that the traffic engineering is very hard, which, so I'm just simply writing TE. TE is representing to traffic engineering. So the traffic engineering in IGPs is very hard. But talking about TE in BGP is easy. So that's what one thing we have with the differences between the IGPs and BGPs.